Everyone, welcome to the Code Nomad channel. Today we're diving into a super cool code design pattern that can help you write cleaner, more manageable code. The binding properties pattern or the observable properties pattern. Why the binding properties pattern? Go is awesome because it's so simple and clear. But when you need to manage changing data or build responsive applications, things can get messy fast with lots of repetitive code. Think about a UI where a user's name needs to update in 3 different places. Without this pattern, you'll be passing values all over the place. The binding properties pattern, inspired by reactive UI frameworks like Flutter and React and functional programming, lets us create observable values. This means you can wrap a value so that other parts of your program can subscribe to it and get notified automatically whenever it changes. Thanks to Go 1.18's generics, we can build this in a type-safe and reusable way, without needing a huge framework. This is perfect for everything from CLI tools to backend services. Let's have a look at what it actually looks like. Here you have a nice diagram. The observable property is a generic struct of type T. It contains a value of type T, that is the current value of the property. Then there is the observer's map. A map is like a slice. Slices should be familiar. A map is like a slice of associations. It associates a key, the observer ID, to a value, the observer. That means we can access observers by their observer ID. That's basically it. Because every key needs to be unique in the map, we have a next observer ID. That means when we subscribe or add a new observer, we set the observer to the current observer ID and we add one to the next observer ID. That means we always have a unique observer ID. Next we have a mutex. Mutex stands for mutual exclusion. It allows us, or it enables us to lock some parts of a code for just one thread. It means just one thread can access the code or the resources in that part of the code. And we must also release it, of course. This is a read-write mutex. I shall come back to it later to explain what it is, because it's quite convenient. In our set method, as we shall see, our observers are executed asynchronously. That means we need a way of waiting for them to finish, and that's what the wait group is for. I shall explain later when we come to the code of the set method what it is and how it works. The observer function I already mentioned, the observer, is basically a function. It's a generic function. It receives an old value and a new value. That means you can compare the two and take action upon the difference or non-difference between the two. The main methods of the observable property are the get and the set method, of course, and the subscribe, which returns an observer ID, and the unsubscribe, which receives an observer ID. As you can see, we need the observer ID to identify particular observers. The next thing I want to discuss from this slide is the person struct. We're going to have an example of a person that has a name and an age, and it has an observable property of string and observable property of int. That's it. The rest of the slide I shall include it in a GitHub repository, which is linked below, is more explanation and the advantages, etc., etc. Now, let's start on some code. We have the main package here and the import. We need to import format and sync. Format is needed for printing out, because in our main program we'll be printing out some things. And the sync package contains the wait group and the mutex, amongst others. Next we define the observer and the observer ID. Well, the observer shouldn't come as any surprise. It is a generic function which receives 2 parameters of type T, and the observer ID in our very simple case is just an int. Let's go back to the presentation. Before we implement our observable property, we will discuss the read-write mutex. Normally speaking, there is also mutex in sync. It locks part of the code for writing and for reading. Only one thread can write and read at the same time. That is not very convenient in many cases. Sometimes you need to read a lot, and reading doesn't change the value or doesn't change the resource at all, doesn't modify it. This mutex allows multiple readers to read and only one writer. Then it ensures exclusive access for writers to prevent conflict. Reads are concurrent and safe. There's no interference between readers, and only one writer can modify the value at a time. This prevents race conditions during updates, ensures data integrity, and is critical for multi-threaded applications. Let's have a look at how we implement this. Again, this shouldn't be too difficult, I think. Again, we have the value, the observers, the next observer ID, the mutex, and the weight group. I also added, for our own convenience, a new observable property constructor function. This basically receives an initial value of type T, because observable property is a generic struct, and it sets its initial value. It initializes the map, because if we don't do that, map will be nil and we get all kinds of nasty errors. And it set the next observer ID to 0. Mind you, next observer ID is local, so to say, to the observable property it is in. Now we can implement our first method, which is the get method. This is not too hard. We need a read log, so we acquire a read log or try to acquire a read log. We return the value and we make sure that the read log is released before the function exits. So let's have a look at how that works. Go back to the code. There we have it. The set method, however, is a bit more complicated. We need a write log in this time or this time I should say, because we are going to change the property, because it changed the value. We first need to store the old value. We need to make a copy of the observers, because if we don't do that and we go to the current observers map, if it's not in the write log, it can be changed, it can lead to all kinds of problems. And before we notify that, before we start real notification of the observers, we release the log, and so then we iterate over the observers and do the panic handling where needed, and we have the old value there. Well, this all sounds very cryptic. Let's have a look at the code. So let's walk through it. Here we make a log. We acquire a log, a write log this time. Then we copy the old value and set a new value. And then in this loop, or in this section, we create a new observers map and we copy the observers map from the observable property itself, making a copy, that is, a snapshot, I would call it. Then we can unlock the write log because everything that needed to be saved is saved. And we start iterating over the observer. We copy the observer inside the loop and we add 1 to the weight group. That means the weight group will have another thing to wait for. In the go function itself, and that means we do it asynchronously, we make sure that this increase in the weight group weight count is negated by calling done. The second function, the second defer function here, is making sure that if there is a panic, it is handled. we handle it in a very simple way here. In production, this would probably be more complicated, notifying all kinds of systems, who knows what, or retrying, or I don't know what. For simplicity's sake, I just did this. Finally, we call our observer with the old value and the new value. Once we're done with calling all the observers, we make sure that they are finished by calling the wait functions on the wait group, wait function or wait method on the wait group. That's it. Next, we're going back to another screen. We have subscribing and unsubscribing. Subscribing means we add an observer to our observers map, assign an ID, and return this ID, new ID. The unsubscribe method is a bit simpler. It reserves an observer ID, it acquires a lock to the observable property, and it deletes this observer. Simple as that. Let's have a look at how they work. We'll start with the subscribe function, because it's a bit longer, only a bit. We start by acquiring a write lock and make sure that lock is released before the function exit by using the defer keyword. Get the current ID and set the observers ID of the observers map to the observer by using this ID as its key. Then we increase it and return the old ID, because that's the thing that's being set. The unsubscribe method is much shorter. There it is. Again, a write lock, because we're going to change the observers map. Next, we make sure that the write lock is released before the function exits, and then we call the delete function on the observers map with the ID. That's how we delete key pairs, key value pairs from maps. And then we have a simple utility function that we will use in the main. This isn't very difficult. We want to know how many observers there are for a certain property. Again, a read lock, because we're not going to change anything. We make sure the read lock is released by using defer, and then we return the length of the observers map. Simple, I think. Next, we're going to have the person struct, and that is basically, it has a name and an age. Those are both pointers to observable properties, and it enables tracking updates to both fields. Let's have a look. As you can see, we create, we have observable properties, generic observable properties, a string and an int. I also provided, and I should add some curly braces there, a constructor function, and this receives a string and an int, and it wraps them automatically in an observable property. Next, we have 4 methods getter and setter methods, which will be used to set the name and set the age. Again, I will come back to that later. It's very important if you want to take advantage of this observable property and keep the data consistent. It's almost compulsory, well, it is compulsory, to call the set and get method on the observable property and not change it yourself. So that's what the set name and get name do. They receive a name or an age, a string or an int, and the get function return a string or an int respectively. That's basically it. Let's go back to the code and let's have a look at some tests. This is a bit more code than you are used to, but don't worry. It's basically all very similar. We start by printing out, hey, we're doing this test. We create a new person called Alex. He's 30 years old. And we subscribe to observers. Note that we also store the observer IDs. We do it also for one observer for the age property, and one we forget it. Somehow we forget it. So we can't unsubscribe this one, as we shall see later on. Next we print out the initial state, and then we start experimenting with set name and set age. Finally, we unsubscribe one observer for the name and see what kind of effect that has using this. And we do it also for the second name observer. And we do it for the only observer ID for the age property. Finally, we set the age to 40. And Alice mustn't be pleased. And we should still see the subscriber we couldn't unsubscribe because we don't have the observer ID. Let's have a look at how this works. That went very quickly. Let's make this a bit bigger. We have the original message. We have name observer. We have two name observers. And we unsubscribe name observer 1, name observer 2. So no count there. Age observer. So we have only one age observer. And we set the age to 40, but we still have the observer hanging in there. That's it. Why would you want to do this? Because these are extra hoops to jump through. It replaces direct use of raw strings and int types. It enables tracking of changes to values. You can even think that you might build an audit trail using this. The notifications to observers are automatic. They are registered to listen for changes. And all components reflect the latest data. That's very important. It reduces the risk of inconsistent state across the app. It also simplifies state management because update logic is centralized, and because it's thread safe, it minimizes manual synchronization efforts. Again, I already mentioned this, use the get and set methods on the properties, otherwise the subscribers won't get notified. The consequences of not using get and set, observer will not be triggered and state changes may go unnoticed, and that results in inconsistent state. So always use the provided methods for state management, and anyone who used React will vouch for that. Why? Because it keeps data consistent, but it also prevents some hard to debug issues, and that's in your benefit. Again, a summary. It's elegant state management, that's a big advantage. Because the type safe observers, we do it with generics, so it ensures strong compile time guarantees and reduces runtime errors. It also enables robust and testable data flows, and it keeps the code clean. Very, very important. So all in all, you can see that this pattern has many advantages. I would suggest that you have a look in the GitHub repository, which is in the link below, and have fun with it. Please leave some comments and like this video so I can make more. Thank you and see you in the next one.